Hello, parents and any teachers or students who may be watching. Welcome to Creating Math Ahas. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to be looking at subtraction in grade 1. In the Introduction to Subtraction video, we looked at the meaning of subtraction, like removal, takeaway, or comparison, and we also looked at some strategies, including round and adjust, decomposing a place or decomposing a 10, and then also counting up. And I'd like to look at those strategies and the foundation development for those strategies that we'll be doing in grade 1. Now you can see on this paper some different counters you may see your children using early in grade 1 and moving into grade 2. Some come from what they would have done in kindergarten. You might see some vehicle counters, some bear counters, some animal counters, other types of counters that are in the classrooms. You may see unifix cubes, named this way because they connect in only one way. You may see base 10 materials. Now these cannot be broken apart where these could. So these have 10 in them, these rods. We have units. There's also a 100 version, a 10 by 10, and 1,000 block. As your children move up through the grades, they may be using these, or you may see photos of these or pictures of these in their materials. You might see something as simple as spray painted lima beans. So just counters to help them act out the problems. So let's take a moment to look at some of the problems we did in the intro video, or the types of problems. And I'd like to look at a problem like 62 minus 29. Now, for 62 minus 29, we did one strategy called round and adjust. And essentially, I'm drawing these for 10s as just an efficient way to draw a 10 and that for a 1. In this particular problem, round and adjust, we would remove 30 and give back 1. To remove 29, remove 30, give back 1. You can see the answer is 33. If I do the same starting place, another technique we use is your children will remove 20, and it doesn't matter which 20 they remove, and then they just break this or cut this into 9 and 1 versus trading. They're going to cut it, they remove the 9, and you can see we still have 33 left. This is decompose a 10, which is just a fancy name for break it up, right? And then if I have a same starting point, you may see your children remove the 2 1s first, and they remove 20, and then they break this, knowing that 9 is the same as 2 and 7, they break this into 7 and 3 because they need 7 more, and they remove that. So some of the strategies that we looked at in that Intro to Subtraction video, I'll try to leave the link below so you can see that, and that will give you an overview of the strategies across the grades. But I often hear parents say, well, my child already knows the answer to 12 minus 9. They know it's 3. Why do they need to do all of the things that you're doing with them? Well, knowing that 12 minus 9 is 3 is great. It's helpful to know your facts. But you see, knowing those facts won't help me use these strategies to solve more complex problems that we're going to be getting in 2nd, 3rd, 4th, 5th grade and on up. The other nice thing is these strategies will work for fractions and decimals when they do get up into 4th, 5th, 6th grade. So let's look a little bit at some of these strategies and how we will spend time with them in developing 12 minus 9. Now I'm going to use this model versus this model for 12, and I hope you'll see why. And I hope you see as you watch these videos that we're purposely selecting certain materials to help your child understand and make connections for them. So this one, because this one won't break apart, we'll choose to use this one, okay? Now, think about that first strategy was round and adjust. And your child may be asked to act that out and draw a picture. Now, think about if I'm using round and adjust, what do? I remove the 10 and then I give one back. I adjust. The picture for that, if I start with the same line for 10 and these for ones, what did I do? I removed the 10 and I gave one back. Round and adjust. Now, another strategy that we talked about is decompose a 10. Okay, instead of removing the whole 10 and giving one back, your child may break it up into 9 and 1, and then I remove the 9. Okay, so I'm decomposing the 10, I'm breaking it. I'm not exchanging it for 10 ones. I'm just going to picture breaking this into 9 and 1, and then I can remove the 9. Now, our other one that I just showed you was decomposing a 10, still that decompose a 10, but some children remove the ones, decompose a 10. They'll remove the ones first. They take care of the ones, and then they break this into 7 and 3, so they can remove the 7. So my picture might look something like this. So again, we aren't teaching these strategies to prevent your child from learning the facts. Not at all. We're wanting them to understand, use the facts, they're helpful, but also understand the foundation and play around with how to break numbers apart, decompose them, how to use that to find those answers, which will help them when they get to those more complex problems like this in grade 2, 3, and on up. Okay, so that's one strategy. Another strategy that we have is called a counting up strategy. And the counting up strategy, you may see your children use a tool, I guess I'll call it a part total chart, or a total part chart. And you see, I'll use both names. If I were to turn it this way, I tend to call it a part total chart. Part, we're looking at totals. This is more of our addition type model, I think of it. I have the parts, I'm combining them. What's my total? When I turn it this other way, this is my total part. Now, just real quickly, if I were working with 62, see, I'm counting up the 62. I started with 29. That was my first value we had, and we were trying to remove. Sorry, I'm having a bit of a manipulative challenge here. I've got 29, and I'm trying to find out, thinking in terms of missing add-in, how many more to make 62. So 29, I'm going to count up. 1 is 30, 40, 50, 60, 61, 62. You see, how many more did I need to make 62? I need 33 more. Still have 33 as the answer. Now, in our case, I'm thinking of 12 as my start. Here's my total I want to get to. And I've got 9 as the start. And I'm trying to figure out how many more will I need to get to 12. Now, if any teachers are watching, do you notice how I'm not just, I'm putting these in a particular organized fashion, right? I'm using more of a 10 frame look because for efficiency, I don't want to have to keep counting the quantity here. I can look at this quickly and know it's 9. I could use a domino dot image. Parents, a 10 frame image you may see is a 5x2 set of squares, usually as a row of 5 squares or a column of 5 squares, column of 5 squares put together. And it's a 10 frame. And it's a model for us to know how many more to make 10, how many fewer than 10. We use it for teen numbers later. So you'll see that more in other videos. But just notice I'm organizing this so I know immediately 9, and then I count up 10, 11, 12. And now we come to this model. Now, many of us growing up used a number line model. And the thing with number line models is you have infinity going on between every two numbers. That's complex for your grade 1 child, right? So you might see your child use this number track idea, right? Where we're only looking at the whole numbers. Now, for counting up in this particular case, essentially, if I'm still working with 9 minus or 12 minus 9, see, I start at 9, and then I figure out how many jumps I need to get to 12. Now, I might use 2 counters. You might see the child leave a counter and then make jumps. The reason I tend to use 2 counters, and if your child's having a hard time being able to count up like that, sometimes it's because they no longer have their start point in their sight, right? So I can start at 9. I could do jumps of 1, or I could do a jump of 1 to get to 10, and then a jump of 2 to get to 12. Now, let me show you this sheet. This sheet is a way for us to record what was going on here. So we acted out, right? We've got this number track, and now we have a way to record. This sheet actually goes to 20, but we're going to look at 12 minus 9 again. But notice my start is at 9, and I want to get to 12. The question is, how many jumps again? Now, we acted out 1 where we made jumps of 1 and landed on 12. Another possibility, as I said, excuse me, is to make a jump of 1 and then make a jump of 2. And we start to look at efficient ways to make these jumps. Okay. Some children will make jumps of 3, right? Because they know the answer is 3. But we're really wanting them to start to picture ways to jump other than just a total jump. And that's one way we'll make it more complex for them when they get into upper grades. Because think about that 62 minus 29. I may know the answer is 33 and make a jump of 33. But if I want to make it challenging for your child, I might say, great, I want you to do it in exactly 6 jumps. 1 must be 18. See, I don't need to go to larger numbers, but that makes it more complex. So we want your child flexible, right? When we looked at the 5 strands in that first video, one of the things with procedural fluency was flexibility. It's not that they learn one of these ways to subtract, it's that they can use all of these different ways. They are playful with numbers. They can act things out. They can draw related pictures, right? They can show how all of these things come together and will end up giving you the same answer no matter which technique you use. Now, I want to do one aside just to mention that I've been doing this drawing for 12. Your children more than likely won't start here. That's kind of abstract. That's a bit of a leap. They may start by doing a drawing of the rod of 10. See, they're going to end up drawing a picture. Yep. They're going to end up drawing a picture that looks like this. That rod of 10 and the 2 1s. See, they draw what they see. So we're going to have this kind of a drawing to start. And when they cut it, they can cut it here like we did and have 9 and 1. They start here, and we'll move them in grade 1 and into grade 2 into that type of a drawing. But you'll see these progressions are very purposeful because we're building that foundation, not to replace knowing the fact 12 minus 9, knowing it's 3, but to add to that understanding the foundation needed to be able to mentally compute problems like 62 minus 29. So if this video was helpful, I hope you'll like it. I hope you'll subscribe so you know when future videos are coming up. I also hope that if you have children in other grades, you'll look at those grade level specific videos for subtraction. And I hope to see you in those other videos. Thanks for watching.